Hi, in this quick tutorial I'm going to show you how to download and run a C++ program um, using nearest neighbor interpolation on Visual Studios. Alright, so what I need you to please do is go into the Moodle and download this lab.zip file, alright, as well as also please download these test images. Alright, if you don't use all of them now, it's okay, but you probably will use them later in other projects and other programs that you will want to create. After downloading them, please extract those folders and files into an appropriate directory that you're happy to work with and that you can order correctly. Alright. After doing so, please navigate to your lab or to the lab directory. You want to look for a SLN file. That way you can open this up in Visual Studios directly. Okay, so by doing so it will open up Visual Studios. In the video description I will attach some links and descriptions on how to install Visual Studios and a C++ compiler called MingW, in case you don't know. I'm not going to do a video on that because I think there's some other resources that provide better solutions. Alright, after you're done opening up your project, please scroll down and navigate down to test.cpp. Okay, you want to open up this file. All of these other ones are C and .h files, so you do not need to open them or mess with them. It's quite obvious which one you want to work with. Okay. The next step I recommend you guys do is please just delete any of other functions that are found in this folder, as well as all information inside the main that is irrelevant. Alright, so just leaving return 0. For this program we will only need really image.h library. I believe I'm going to leave these other header files because you will probably need them for later programs you will want to run, such as bicubic or gamma and so on and so forth, which we will explain at a later stage. Alright, for now what we want to do is we want to obviously start with our nearest neighbor interpolation. So what you want to do is you want to start off by deciding what image you want to use. Alright, so let's actually quickly navigate to our file system, and I want to go to our image sets. Okay, I want to select the image you want to use. In this case we're going to use a grayscale image and we're going to use Barbara here. Alright, so please go and copy or cut, it's up to you what you'd like to do, and let's take it directly into our labs folder. Okay, so the one directly after the SLN file. Over here we are going to create a new directory. Right, this will just be easier to manage our images and things we work with. Alright, so I'm going to call it images. Alright, inside this folder I'm going to paste Barbara, which you can see we have done. Okay, and I'm going to open it like that so you can see that there's an image. I've also chose this image because its dimensions are 512 by 512, so it is a square, right? Which might be easier to work with in some instances. Right, in the meantime also please delete any other PNG files that will be irrelevant. So there's read, small and test for the time being are pretty irrelevant, so please delete those files. Okay, once this is done, please navigate back to Visual Studios and let's start with our program. So to start off, we obviously want to load in or take in our Barbara image, which we will have here, okay, in our images folder. Alright, so what we're going to do with nearest neighbor interpolation is we're going to take this image and read it. Alright, we're not going to manipulate it, we're not going to change any data. All we're going to do is read in the data, perform some calculations on it, and create a new image which we will save in this directory as well. Alright, so let's start off by creating a grayscale image. Alright, and we will call it image. Okay, considering we will be using an image. Next, we will also need to create a variable to store our new image in, which we can call changed image. Alright, so that we know which image is which. Okay, I'm also going to set the size of the new image to 300 by 300 pixels. Alright, you can obviously adjust this as you like. If you wanted 500, or maybe not 500 because you won't see much change, but maybe 1000, or bring it down to 100, and you will really see the image quality start to deteriorate, or deteriorate over the size of the image or the new dimensions that you wish to choose. Okay. Next, what we're going to do is we're obviously going to load in the image that we want to perform actions on. So let's load it in. Now, I remember we stored it under a directory called images, and it was called Barbara. Okay, it was a .png file. Okay. After done reading in this file, we obviously now need to create our scale factor. So in order to do this, we are going to create a float variable that will store our scale factor, and let's call that variable scale f. Okay, we will assign it the value of our current image, okay, our image's width, divided by the changed image's width. Okay, so we can simply say here image dot get width, okay, divided by image dot changed image dot get width. Okay, so this will now create our scale factor that we need. We also need to convert this to a float. I do apologize, cast this to a float. Okay. Alright. Next thing we're going to do is we actually need to now create our image. So we're going to do this by simply running a for loop through every pixel in our new image and decide what value that image should be given. Alright, so we're going to create a for loop, and in this one we're going to start from the y-axis. Okay, the outer one will always be the y-axis, and this y variable will need to be less than our new changed image's height. Okay, so we're going to say changed image dot get height. Okay, because we're working in the y axis, and provided that it is less, we will be plussing 1 to it. Okay, so next thing we will be doing is we will now create a for loop for our x-axis. Okay, doing the same process. Int x is equal to 0, and we will be continuing this process for as long as x is less than changed image dot get width. Alright, because we're working on the x-axis, so we need to use width. Okay, and provided that that is all that x is less than the changed image's width, we will be plussing 1 to it indefinitely. Okay. Next, we obviously need to save, or we need to create our image using our scale factor. So we will simply do that by saying the changed image at our x and our y value, okay, will be equivalent to the value at image at x and y, but dependent on our scale factor. So the current value at x times the scale factor, okay, as well as y times the scale factor. Okay, now because this is a square image, okay, that both sides are equivalent, you can have one scale factor. Alright, if you will be dealing with an x and a y, or the x and the y would be different, you, I guess, can create two scale factors depending on the width and depending on the height, and make that change accordingly. Alright, of the scale factor of x and then the scale factor of y. For this instance, we don't need to do either. Okay, we just can do one. Either one will be sufficient. Right, after doing that, we obviously now need to save our image. So we will be saving our changed image. We will save it as new Barbara, okay, so that we know which one is the old one and which one is the new one. Alright. However, I would also like to save it directly next to the previous one, so we're going to save it under the images directory. Okay, it's the same one here. Only difference is we've created a new PNG file and we are saving it. Okay, now you can see that this one is a completely different variable to this one. Alright, and we have not manipulated this image file at all. However, this changed image, we have created it from data that we have obtained from the image file. Alright, after doing so, there is no more steps you actually need to take, so you can simply build and compile the program and run it, and it should create the new images accordingly. Alright, so we'll just wait for this to build and run and debug, which I believe it has done, and the program is now finished. So now we can go to our image folder. Alright, and inside our images folder, you see there's nothing on the outside, but if we go inside our images folder, we see there's a new image called New Barbara. So I would like to open up these two photos so that we can compare them side by side. Okay, as we can see, originally without any modifications, this one is already the new Barbara image is smaller than our previous Barbara image. So if we zoom in to the same size as our current one, we can see that we have obviously a loss of data and a change in the way the image is looking through lines that have come through the original image. I do hope that this was a helpful video. If you would like to use this same process on color photos, you just need to simply change this information here to a color image, and you can start working with colored variables and perform different actions on it, and different algorithms and approaches. That's it for now. See you in the next video.